Hi, and welcome to the fourth section on intermediate Python. So I got a request to talk about generators, and I'll do that next time. This time, I'll talk about the difference between iterables and iterators. And this is a distinction that when we're speaking, we don't always manage to do. We sometimes say, yeah, a list is an iterator, even though it's an iterable and not an iterator, but still it's good to understand this distinction. So what I'll try to do in this video is to show you the distinction between an iterable and an iterator. It's not something difficult, it's just slightly confusing because the names are so similar. So let's head over into a Jupyter notebook and take a look at this. So here I am in a Jupyter notebook. I've started to fill some of this out, we'll gradually work through it. So let's just start at the beginning, you don't need to read anything below here for now. So I want to start with iterables, as you can see here, and the question is, what are iterables? So the kind of useless explanation is that iterables are things that can be iterated over. So this might give you an indication that you can use an iterable in the for loop, for instance. We'll talk a bit more clearly about this. So first of all, let's just begin with this intuitive definition of being iterated over and see if we can come up with a few examples. So first example is lists. So here I can take any name in. Let me just make a list here with our names. And then I can do whatever. Let's just print it out. Here you see it. So lists, they are iterables. So a few more examples. We have strings. They're also iterables. So I can take each letter in, let's just do in my name. Here again, I can do whatever. Let me just print it out, as you can see. And finally, let's take dictionaries. So here, let's just make a dictionary where we have apples, let's say 1, oranges 2, doesn't matter what it is. And here we can print item. Notice here before I run it that this is maybe the first point where what's actually being done is a bit non-trivial. So in these cases, the lists and strings, it's essentially only one way to iterate through them. Here, one could have implemented different choices. You could iterate through the keys, or perhaps through the values, or perhaps through both. But as you can see in Python, the default is iterating through keys. But even if it's not completely obvious, dictionaries are iterables. You can iterate over them. So now we have some examples, so let's try to gradually move away from this intuitive definition. And a more precise one is that an iterable is an instance of a class that has an iter dunder method. So if you recall from classes in Python, then you can make so-called dunder methods. This is just essentially methods that have 2 underscores first and after the name, and the names are reserved. So you have some like init for initializing, eq, for comparing different instances of classes, and classes can also have an iter dunder method. And an iterable is essentially just some instance of a class that has this dunder method. So let's try again to do this with lists. Let's just have this collection of me and Stina's names here as a list. And then I can form a new variable. Let's call it iter names. This is names. And then I call the iter dunder method. You can see here that this kind of works. So I can try to print this out. Here you can see that this is a list iterator. Notice now that this says iterator, not iterable, right? So this is the different variant. So a list is an iterable. It has this iter dunder method, as you can see here. And what's being returned is an iterator. Again, here what the iter returns is an iterator. And on iterators again, we can call the next dunder method to get the next value. So you can think here of this iter names as essentially some object that represents like in Stina, and we can now iterate through them very manually by using the next method. So I can do iter names and then do next. Running this, I get Eirik, and running it again, I will get Stina. So this kind of remembers the state I'm in. If I now try to do it a final time, and you can see there's kind of nothing left here, then what's happening is that we'll get a stop iteration. So this is just an exception saying, hey, there isn't anything more here. We have to stop this iteration of iterating over it. And so iterables have an iter method. When you use the iter method, we get an iterator. They have a next method so that they can gradually go through each element. And when you're using a for loop, let's just scroll up all the way here. What's really happening is that under the scenes, this is converted to an iterator by using the iter method. And then next is called all the way through the whole thing and then just catches the exception at the end. So all of this manual work by calling the iter and next dunder methods is just done by for loops automatically. So a kind of small simplification here is that in Python you can also use the built-in functions iter and next instead of calling these dunder methods. And that's pretty useful. So let's just do fruits maybe. Let's do the same as previous. We have apples, which were 1, and oranges, which were I think 2. It doesn't really matter, but still here we can make now fruit iter, because it's fruits iter. And we can just use the iter function here instead of this double underscore iter and pass in fruit. And now we can also just do next of the fruits iter. Oops, small spelling mistake. Here I get apple. And if I run it multiple times, I'll still get apple simply because now I have everything in the same Jupyter cell. So now every time it gets initialized again. But if I decide to move this, let's just copy this, move it down here, first run this cell, then run this, then I get first apples, then oranges, and then of course the stop iteration. So if I remember back to when I first learned about Iterables and Iterators, I was a bit like, okay, so the only purpose, it seems, of an iterable is to produce an iterator that I can then loop over. Why not just simply deal with iterators and that's it? I mean, it seems now that iterables, think lists, are just a kind of stupid way of doing iterators when you could have just done it directly. It just seems like iterators with extra steps, right? But the fact is that once you turn something into an iterator, it may lose much of the previous functionality. So let me just demonstrate this. And just for reference, here's the comment I said a bit too early, saying that in a for loop, you implicitly first convert the iterable to an iterator with the iter method and then call next on it until you reach the end. But in any case, we can again do, let's do the names. Let me just fetch this. We can make a names iter variable, just using iter. Seems that this is just a better thing than names. But the fact is that this thing here has now forgotten much of the functionality of classical lists. So if I do names iter, try to say index at 0, I'll just get a type error saying that, hey, this is not subscriptable, you can't do that. And if you take any of the classical methods like append, maybe I want to append the number 17, this doesn't work. List iterator doesn't have any attribute called append. So if you take now this name iter, and look at its methods, you can do this with a dir function, then here you can see it. And you can see that this has a lot of special methods or dunder methods, but it doesn't have any of the append, insert, and so on that classical lists have. So before you start actually iterating, it's good to just work with classical lists because they have a lot of nice functionality. And you might be at the point now that you say, okay, Eirik, I think I understand. So iterables are like lists, dictionaries, tuples, strings. When you take the iter, they produce an iterator, and the iterator you can call next on. But how would you ever use this? Are you saying to me that I should manually go and call the next function on lists? This is not what you're supposed to be doing. You're not supposed to use these functions here explicitly to loop through lists. If you want to make your own classes, these are super useful. I hope they're also useful for understanding this difference between iterables and iterators, but I think it's good that we now do a quick practical example of when you would actually use, say for instance, the iter dunder method. So here when to use this, say that we're making a class, and I'll call this pair of RGB colors. I think it's kind of obvious what this is, but let me just make a docstring. This is a class that works with 2 colors in RGB format. Let me just quickly make the init function. This is just standard class stuff in Python. So it takes into colors. This is color 1 and color 2. And let me just assign these to the same names. Now we have this class, and maybe let's make an instance. Let's just call this, okay, colors, maybe not so creative, but let's try with this. Pair of RGB colors. So I need to pass in color 1. Let's do something that's completely red. So that's 25500. And let's do something that is green, I guess. So this is color 2. This is 0, 2550, red, green, blue. Yeah. So here I have the colors. Creating this, great. And you can imagine that you could fill this class out with interesting behavior, like for instance calculating complementary colors and so on and so on. I don't want to do that because that's not the focus. What I will do is that it's sometimes convenient to iterate through all the colors in this thing here. But if I now try to do let's, for color in colors, print color, I simply get a type error saying that, hey, this thing is not iterable. And why would it be? We haven't implemented any functionality for being able to iterate over something, right? This thing has no idea what I would mean by iterating. I think we have an intuitive idea that I should first print the first color and then the second, but we haven't implemented anything. So how would we go about doing this? We need to have an iter method. So this should return an iterator, right? And the thing is that you often don't need to create these completely from scratch. You can do this, but often don't need to. What you can simply do, so since I just want to first print out color 1 and color 2, I can just put self.color1 and self.color2 in a tuple, for instance, like this. I could have tried to just return this. Let's see what happens. Still looks like it doesn't work, right? And the fact is that this here now doesn't return an iterator, it returns an iterable, and that's not what we want. We want the iter method of something that's iterable to return an iterator. I really hope you're with me on this. I know that the words are very, very similar, but try to focus on that the iter function should return an iterator. So what I need to do here is to simply do the iter of this again. Because a tuple is an iterable, we call iter on it, the shorthand version that is built in Python. This gives us an iterator. And now this class here has a dunder iter method that returns an iterator. So if I run everything, it looks exactly as it should. You can see here that definitely the code at the end here is not very complicated, but if you don't understand this difference between iterables and iterators, then this bit here, this def_iter, return iter of this, looks kind of strange. So hopefully, if you look at this for a bit, you can convince yourself that now this pair of RGB colors is now an iterable. It has an iter method that returns an iterator. That means that when you do it in a for loop, this unpacks everything cleanly, calls implicitly first the iter function, so you get this thing here, and then implicitly calls this next function on this to essentially loop over it. So this is what I wanted to say in this video. This is more of a conceptual thing between iterables and iterators, but I really think that this is something one should know. It certainly makes things like this a lot easier to understand. We'll of course continue this series in the next video where I'll talk about generators. And having this foundation of understanding iterables will then be super useful. So thanks and have a nice day.